In a world dotted with islands, each a storybook of nature's whims, there lies an island so bewildering that it sends ripples of alarm through the global scientific community.
As I go through the historical imagery, I can actually watch it move.
This narrative embarks on unraveling the enigma of an island that, far from being a mere speck on the map, harbors secrets that both fascinate and frighten scientists around the world. Mystery Islands of the World. A brief overview. Islands, by their very nature, are emblematic of mystery and isolation. Emerging from the depths of the oceans, these landforms are the Earth's way of showcasing its dynamic character and diversity. They range from the paradisiacal to the perilous, each with its own unique story, shaped by millennia of geological processes, human history, and ecological evolution. Islands are born through a variety of natural phenomena. Some emerge from volcanic eruptions, where molten rock bursts from the Earth's crust and cools to form new land amidst the sea. Others are the product of coral growth, gradually forming atolls that rise above the ocean's surface. Then there are those sculpted by the relentless forces of erosion and sediment deposition, carved out by the hands of time and the currents of the sea. Many islands serve as ecological havens, harboring species that have evolved in isolation, untouched by the hand of man. These secluded ecosystems are treasure troves of biodiversity, offering insights into the processes of natural selection and speciation. The Galapagos Islands, for instance, played a pivotal role in Charles Darwin's formulation of the theory of evolution, their unique fauna sparking the realization that species adapt to their environment over time. Beyond their natural allure, islands have also been the backdrop for human intrigue and drama. They've been hideouts for pirates, sanctuaries for exiles, and the sites of utopian experiments. The history of islands is replete with tales of treasure, tragedy, and triumph, from the legendary Atlantis to the penal colony of Alcatraz. Islands are not just subjects of curiosity for their ecological and historical significance, they are also at the forefront of scientific discovery. Researchers flock to these isolated laboratories to study everything from climate change impacts to invasive species dynamics. Islands provide a controlled environment, a natural petri dish in which the consequences of environmental changes and human actions can be observed in real time. However, not all is idyllic in these isolated retreats. Some islands have become the centers of controversial scientific experiments or ecological disasters, their isolation making them ideal for activities far removed from the public eye. Nuclear tests in the mid-20th century turned some islands into radioactive wastelands, while others have been sites for biosecurity labs, housing pathogens that could devastate populations if ever released. Among these myriad islands, there is one that stands out for its ability to perplex and perturb the scientific community. Its story is not just one of natural wonder or human history, but of something far more mysterious and potentially ominous. This island, shrouded in secrecy, has sparked debates and fears, not for what is known, but for the unknowns it harbors. The floating island phenomenon. In the vast expanse of the Pacific Ocean, a phenomenon unfolded that captured the imagination of the world and puzzled the scientific community. A floating island, an immense mass of pumice stone, drifting towards Australia. This floating island was not just a curiosity, it was a testament to the Earth's dynamic nature, a reminder of the powerful forces that shape our planet beneath the sea. The origins, journey, and impact of this floating island offer a fascinating glimpse into the world of geological phenomena and the challenges they present to scientists. The story of the floating island begins with an underwater volcanic eruption, a forceful event where magma from the Earth's mantle finds a release on the ocean floor. As the molten rock meets the cool ocean water, it solidifies into pumice, a porous and lightweight volcanic rock. In this particular event, The eruption was so colossal that it produced an estimated 1,000 million pieces of pumice, all floating en masse due to their buoyant nature. This created a floating island twice the size of Manhattan, an astonishing sight by any measure. The floating island's journey across the Pacific was not just a spectacle, it was a subject of intense study. Scientists were keen to understand the currents and winds that propelled this mass across the ocean. Tracking its movement provided invaluable data on oceanic currents, wind patterns, and the distribution of marine life. As the island drifted towards Australia, researchers seized the opportunity to study its interaction with marine ecosystems, noting how the floating pumice served as a moving habitat for organisms, aiding in the distribution of marine species across vast distances. The floating island presented numerous scientific challenges. The primary concern was the potential impact on marine ecosystems and coastal environments. There was speculation about the island's effect on shipping routes and whether its arrival would smother coral reefs near Australia, disrupting marine biodiversity. Scientists embarked on studies to assess the ecological footprint of the pumice island, monitoring its effect on water quality, marine life, and coastal ecosystems as it approached the Australian coast. Moreover, the phenomenon spurred questions about the frequency and scale of such eruptions and their role in the ocean's geological processes. The floating island was a vivid demonstration of the Earth's geological activity, prompting discussions about the monitoring of underwater volcanoes and the potential for future occurrences of floating islands. The study of the floating island yielded significant insights into the natural world. It highlighted the interconnectedness of geological and biological processes, showing how volcanic activity can influence marine ecosystems across vast distances. The event underscored the importance of satellite monitoring and oceanic research in understanding and predicting the movement of such phenomena. The enigma of Tonga's muddy island. In the South Pacific, nestled within the Kingdom of Tonga, lies an island that became the center of an extraordinary scientific intrigue. When NASA researchers landed on this seemingly unremarkable island, they encountered a phenomenon that defied easy explanation: a mysterious, clear, and sticky clay mud. This substance, which was neither volcanic ash typical of the region nor any recognizable sediment, presented a puzzle that has since captivated geologists, volcanologists, and environmental scientists alike. The discovery was unexpected. Tonga, an archipelago formed from volcanic activity, is no stranger to unusual geological phenomena. However, the clear, sticky mud did not match the characteristics of any known volcanic byproduct. Its composition puzzled researchers. It was unlike anything they had encountered. The initial theories ranged from a unique sedimentary deposit, altered by the island's environmental conditions, to the residue of an unknown underwater volcanic eruption with peculiar chemical properties. The island itself was a recent addition to Earth's surface, having emerged from the ocean only a few years prior due to volcanic activity. This process, where volcanic eruptions create new land masses, is well documented in the Pacific's Ring of Fire. However, the presence of the mud suggested an unusual aspect to the island's formation, perhaps indicating a novel type of volcanic activity or a previously unknown interaction between seawater and volcanic materials. The enigma of the mud posed several challenges for the scientific community. First, there was the task of analyzing its composition to understand its origins. This involved complex chemical analyses, comparing the mud's properties to known geological substances. Scientists also embarked on geophysical surveys of the island and surrounding seabed, looking for clues about the underwater processes that might have led to the mud's formation. One theory proposed that the mud was the result of a rare chemical interaction between volcanic gases and seawater, creating a kind of natural clay polymer. Another hypothesis suggested that the mud might have been a deposit from an ancient seabed, uplifted by the volcanic activity that formed the island, though this did not fully explain its unique properties. The study of Tonga's muddy island has broader implications for our understanding of island formation and the diversity of natural phenomena associated with volcanic activity. It highlights the complexity of Earth's geology and the potential for discovering entirely new processes and materials. Additionally, the mud's unique characteristics raise questions about its impact on local ecosystems and its potential uses in fields such as material science. The island also serves as a natural laboratory for studying the early stages of ecosystem development on new landmasses. Researchers are keen to observe how life colonizes this new island, with the mud possibly playing a role in shaping the emerging ecosystem. This could provide insights into the processes of biological colonization and adaptation in extreme environments. Despite ongoing research, the origins and nature of Tonga's sticky clay mud remain partially unresolved, embodying the spirit of scientific exploration and the quest for understanding our planet's mysteries. The island continues to be a subject of study, with scientists from various disciplines collaborating to unlock its secrets. Islands with dark secrets, the island of plagues. In the cold waters of the North Sea, near the shores of Germany, lies the island of Rams, an enigmatic piece of land shrouded in secrecy and concern. Officially known as the Friedrich Loeffler Institute, this island has earned a notorious nickname, the Island of Plagues. Its history, purpose, and the controversies surrounding it make it a fascinating and somewhat foreboding place, sparking a mix of scientific intrigue and ethical debates. The island of Reims was transformed into a high-security laboratory to study some of the world's most dangerous pathogens. This decision was driven by the need for a controlled environment, far removed from human populations, where research on infectious diseases could proceed without the risk of accidental outbreaks. The island's isolation provided a natural barrier, an additional layer of containment beyond the sophisticated biosecurity measures implemented within the research facilities themselves. The Friedrich Loeffler Institute on the island of Reims is at the forefront of research on viral and bacterial diseases affecting animals and, by extension, humans. This research includes studying pathogens responsible for diseases like foot and mouth disease, African swine fever, and avian influenza. The goal is to understand these diseases better, develop vaccines, and find treatments to protect agriculture, public health, and global economies from the devastating impacts of outbreaks. The very nature of the research conducted on the island of Reims places it at the center of ongoing scientific and ethical debates. On one hand, the work is critical for advancing knowledge on deadly diseases and for global health security. It represents a proactive approach to understanding zoonotic diseases, which are diseases that can be transmitted from animals to humans, and poses a significant threat in our interconnected world. On the other hand, the concentration of such dangerous pathogens in one location raises concerns about the potential consequences of an accidental release. Despite the high level of biosecurity, the risk, however minimal, cannot be entirely eliminated. This has led to discussions about the balance between the benefits of such research and the risks it entails. The island of Reims holds secrets not just about the pathogens it studies, but also about the methods and outcomes of its research. The work done here is often at the cutting edge of science, pushing the boundaries of our understanding of infectious diseases. However, the island also embodies the constant tension between scientific exploration and the precautionary principle, the idea that caution should be exercised when the stakes are high and the risks are uncertain. The safety measures in place on the island are among the most stringent in the world. The facility operates at a biosafety level 4, BSL-4, the highest level designed to handle the most dangerous pathogens. Researchers work in secure, airtight laboratories, wearing specialized suits that provide complete isolation from the external environment. air and waste are treated through advanced filtration systems to eliminate any risk of contamination. The duality of paradise when beauty hides danger. Islands have long been emblematic of paradise, offering serene beauty, isolation, and a sense of unspoiled nature. However, the duality of these idyllic retreats becomes starkly apparent when human intervention transforms them into potential threats. This transformation underscores the complex relationship between human activity and the natural environment, where actions taken in pursuit of progress or security can inadvertently turn paradises into perilous locales. Human intervention on islands has taken various forms, from the development of tourist resorts to the establishment of military bases and the conduct of scientific research. While these activities can bring economic benefits and advance human knowledge, they often come with environmental and safety risks that can alter the island ecosystems and pose dangers to both human and wildlife populations. One of the most striking examples of this transformation is the use of islands for nuclear testing during the mid-20th century. The Bikini Atoll in the Marshall Islands became synonymous with nuclear tests, where the beauty of this Pacific paradise was overshadowed by the devastating impacts of atomic explosions. The tests not only rendered the area uninhabitable due to radioactive contamination, but also caused long-term health effects on the local population and disrupted the natural marine ecosystem. Industrial activities, such as mining and manufacturing, have also turned islands into sites of environmental degradation. The extraction of resources can lead to deforestation, soil erosion, and pollution, jeopardizing the island's ecological balance. For instance, the island of Nauru experienced severe environmental damage due to extensive phosphate mining, which stripped away large portions of its land, leaving behind a barren and pitted landscape. Moreover, the construction of large-scale industrial facilities like oil refineries and chemical plants introduces the risk of spills and accidents, which can have catastrophic effects on island ecosystems. The delicate balance of island environments makes them particularly vulnerable to such incidents, with long-lasting impacts on marine life and biodiversity. Human intervention has also facilitated the spread of invasive species, which can devastate island ecosystems. Introduced plants and animals, often brought intentionally or accidentally by humans, can outcompete native species, leading to their decline or extinction. This not only affects biodiversity, but also disrupts local livelihoods that depend on native species for food, medicine, and tourism.
3,000 miles from the mainland, a remote paradise that's become a rubbish dump.
The introduction of rats, cats, and other predators to islands has had particularly severe impacts on bird populations, many of which evolved without natural predators and are therefore highly vulnerable. Efforts to eradicate these invasive species and restore island ecosystems underscore the challenges of reversing the damage caused by human intervention. The threat of climate change and rising sea levels adds another layer of danger to island paradises. Many islands, especially low-lying atolls, are at risk of being submerged, which would lead to the loss of habitats, cultural heritage, and human settlements. The impacts of climate change are already being felt on islands around the world, from the bleaching of coral reefs to the increased frequency of extreme weather events, highlighting the urgent need for global action to mitigate these risks. China's island of nuclear ambition. Changguo Island, positioned in the east of China, stands as a stark symbol of the country's ambitious leap into advanced nuclear technology. This island has been earmarked as the site for China's pioneering project in fast neutron reactors cooled by sodium, a venture that signifies not only a significant technological advancement, but also raises a spectrum of international concerns regarding nuclear proliferation and environmental safety. The development on Changguo Island encompasses the construction of two fast neutron reactors, known as the CFR 600. These reactors represent a bold step forward in China's nuclear energy strategy, aimed at reducing CO2 emissions while significantly boosting the nation's energy capacity. The first reactor is expected to become operational in 2023, with the second following in 2026, together generating a substantial output capable of powering two large cities. Fast neutron reactors are a departure from traditional nuclear reactor designs. Unlike conventional reactors that slow neutrons to increase the likelihood of nuclear fission, fast reactors utilize high-energy neutrons. This approach not only allows for a higher efficiency in fuel usage, but also enables the reactor to generate more fuel than it consumes, a process known as breeding. The CFR 600's design is particularly focused on breeding plutonium, a choice that has ignited a debate on the dual-use nature of this technology for both energy generation and potential weaponization. The pivot towards plutonium breeding has not gone unnoticed on the global stage. The ability of the CFR 600 to produce significant amounts of plutonium raises questions about China's long-term intentions, especially in the context of nuclear arms development. Analysts have pointed out that the excess plutonium generated could, in theory, be used to manufacture nuclear weapons, significantly expanding China's nuclear arsenal. This potential has sparked a wave of concern among international observers, wary of a new arms race and the implications for global security. Beyond the geopolitical implications, the development of fast neutron reactors on Changguo Island brings environmental and safety concerns to the fore. Sodium-cooled reactors, while efficient, pose unique challenges. Sodium reacts violently with water and air, raising the stakes in the event of a leak or breach. The environmental impact of such technology, particularly in the event of an accident, could be catastrophic, affecting marine ecosystems and human health in the surrounding regions. In response to these concerns, Chinese officials and scientists emphasize the peaceful and sustainable intentions behind their nuclear program. They argue that the development of fast neutron technology is a critical step towards securing China's energy future and addressing climate change. The project is presented as part of a broader strategy to diversify and clean up the nation's energy supply, reducing reliance on fossil fuels and cutting CO2 emissions. China's nuclear ambitions on Changguo Island epitomize the tightrope walk between technological advancement, environmental stewardship, and international diplomacy. The project underscores the challenges of balancing a country's energy needs and developmental goals with global non-proliferation norms and regional security dynamics. Plutonium production and global security risks. The ambitious nuclear projects on Changguo Island, particularly the focus on plutonium production through fast neutron reactors, thrust China into the spotlight of global nuclear politics and security discussions. The implications of this plutonium production, both in terms of potential military uses and the broader international reactions, are profound and multifaceted, stirring a complex mix of concern, speculation, and diplomatic maneuvering on the world stage. At the heart of the issue is the CFR 600, a fast neutron reactor capable of breeding plutonium from uranium. This technology, while not new, represents a significant leap forward in China's nuclear capabilities, primarily due to its dual-use nature. While ostensibly for civilian energy production, it inherently produces material that can be weaponized. Plutonium,
So the one on the left here with the red solution is plutonium-4.
a key ingredient in nuclear weapons, poses a distinct challenge to global non-proliferation efforts, especially when produced in reactors that are not solely dedicated to peaceful purposes. The potential military uses of plutonium cannot be understated. Even small amounts of plutonium can be used to manufacture nuclear weapons, and the reactors on Changguo Island are projected to produce more than what is necessary for civilian energy needs. This excess capacity has led to international concern over the possibility that China could expand its nuclear arsenal significantly, altering the strategic balance in the region and beyond. the precise nature and scale of China's intentions regarding the use of this plutonium remain subjects of intense scrutiny and speculation. The international reaction to China's plutonium production has been marked by a mixture of diplomatic caution and outright alarm. Neighboring countries, already wary of China's growing military capabilities, view the developments on Changguo Island as a potential threat to regional stability. Meanwhile, global powers, particularly those with vested interests in maintaining the strategic status quo, have expressed concerns through diplomatic channels, urging China to adhere to international non-proliferation norms and transparency measures. The dialogue surrounding Changguo Island also intersects with broader issues of nuclear energy, disarmament, and non-proliferation, drawing attention from international organizations such as the International Atomic Energy Agency, IAEA. The situation underscores the challenges facing the global community in balancing the peaceful use of nuclear technology with the imperative to prevent the spread of nuclear weapons. Beyond the geopolitical and military implications, there is also a significant environmental and safety dimension to the plutonium production on Changguo Island. The operation of fast neutron reactors poses inherent risks, including accidents that could release radioactive materials into the environment. China's pursuit of plutonium production on Changguo Island places it on a diplomatic tightrope, requiring careful navigation of international expectations and concerns. Beijing has sought to reassure the international community of its peaceful intentions and commitment to nuclear safety and non-proliferation. However, the opaque nature of China's nuclear program and the strategic ambiguity surrounding its military capabilities continue to fuel skepticism and unease among global observers. The developments on Changguo Island represent a critical juncture for global security, with implications that extend far beyond the immediate region. How China manages its plutonium production and how the international community responds will have significant ramifications for the future of nuclear non-proliferation, regional stability, and international relations. The situation calls for a delicate balance of diplomacy, transparency, and adherence to global norms, with the aim of ensuring that advancements in nuclear technology contribute to peace and security rather than exacerbating tensions and mistrust.